So in general, what are the system means? It is casual system. Okay, casual non-casual system, followed by linear non-linear system, time variant and invariant system, then static and dynamic system, followed by your stable and unstable system. Okay. Uh, so what you will be doing is we have already seen about your casual and non-casual system. So I have also given some problems. So whether you have completed those problems, so you just type yes or no. Whether you have completed those problems, you just type yes or no. The chat box. Okay. So for DSP, if you are not doing what I'm saying, because the problems what I'm giving are very basic problem only, so it will be easy to understand. So if you're doing these kind of problems only, you can understand and you can move on to the next topic. Okay, so without practicing these kind of problems, it will be very difficult for you. Okay, so actually I have to cover a lot of question in this, so I'll be moving on. So I have given you two problems, right? So I have given you two problems. Whether you have completed or not, you just type it in the chat box. Have you completed the problems or not? So the classroom notes have already been in your Google Classroom. You might have not seen it. Okay, I have put on Friday through. I have put on Google Classroom. Okay, so as overview of lecture 2 and 4, I have given. So verify with that. So it will be easy to understand also. If you are checking with that means. Okay. I think nobody have did this problem. I think I'll be solving. But again, I'm saying if you are not following this kind of practice means it will be very difficult for you, and you can even write in your paper. Okay, you can even write in your paper that it will be difficult for you to clear DSP paper. Okay, so I think Ajay Shankar, right? So Ajay Shankar, it's been saying both are non-casual. Okay, so you can see how you are validating your point. You can see. Okay, so first one we can solve. So example 9. So the given signal is so the given signal is so the given signal is y of t equal to x of t square. Okay. So here what we can do is, as you know, to find causal or non-causal. Okay. The solution. So first what you'll be doing is you'll be putting t equal to 0. So if you're substituting t equal to 0, your y of 0 will be equal to x of 0. Okay. This square will be coming inside. So a of 0 will be 0 square, which is nothing but x of 0. Okay. So this gives out what condition? This gives out your present condition. Okay. Your input will be based upon your present, so your output will be based upon your present input condition. Okay. So now what you have to put is substitute the value. So with this we cannot conclude. Okay. So now put t equal to 1. Okay. Put t equal to 1. So for this, what will be getting? If you're putting t equal to 1, you'll be getting your y of t, that is y of 1, will be equal to y of 1 square. Okay, so it will be equal to, it will be nothing but y of 1. So it is also a present. It is also present. So with this you should not leave it. Okay, with this you should not stop. So what you have to put is, put again t equal to 2. Okay, if you're substituting the value of t equal to 2 means where y of 2 will be equal to, okay, so y of 2 will be equal to x into x of 2 square. So x of 2 square is, x of 2 square is x of 4. Okay, so for the this you will be getting a future value. Okay, here you are substituting the time period to be 2, but over here you will be getting with 4. Okay, so what happens is, this is the, what you can say, this is a future signal. Okay, so in general, present plus future will be, what is the answer? Present plus future gives you what signal? Present plus future is, what signal you will be getting? So you just type, okay, present plus future is non-causal. Okay, so with the simple step alone, you should not stop it. Okay, so you have to substitute up to nearly 3 t values. Okay, so then you check it out. Okay, so this is the answer for that example what I have given as a whole assignment. Okay, so next example 10. Example 10, what I have given was, so the given is y of t equal to t into x of t. So this is somewhat trickier one. Okay, so this is the a trickier concept you have to apply over here. Okay, so it will be somewhat trickier. So again the same thing, to find whether it is causal or non-causal. Okay, so we'll be getting that into the solution. So just see it. So for this you have to put t equal to 0 first. Okay, so putting t equal to 0 means y of 0 will be equal to 0 into x of t. So your value x of 0. Okay, this is what you'll be getting. Okay, so after putting t equal to 1, you'll be getting y of 1 is equal to 1 into x of 1. Okay, so these are all belong to your present. Okay, so next if you are putting t equal to 2 means y of 2 will be equal to 2 into x of 2. Okay, the same thing we are putting t equal to minus 1, that is a delayed time period. Okay, t equal to minus 1, a delayed time period if you are putting means you will be getting y equal to minus 1 minus of x of minus 1. This is what you will be getting. Okay, so here what you can infer, even if you are putting t equal to minus 2, you will be getting y equal to minus 2 of minus 2 x of minus 2. Okay, so here from these signals what you can infer is that even if you are putting a positive time period, okay, or the present 0 or the delayed negative signal if you are putting, you will be getting only the what kind of signal you are getting? You'll be getting only the present value. So only the present value you will be getting. So the catchy and tricky point is, if there is only present, if there is only the present value is there means, the present state is there means, if there is only the present state, then what you will be getting is your signal will be a causal. Okay, so this is a tricky point. Okay, if there is only present and there is no future and past means, okay, if it is not present means this belongs to only a causal system. Okay. So another one tricky thing we will be seeing. So example number 11. So example 11. So given they have given a signal y of t equal to x of minus t. Okay, so this is what they have given to find causal or non-causal. Okay, that's the thing that you have to find. Okay, so solution will be going. So now you put the value of 0. Put 0. You will be getting y of 0 equal to x of 0, which is nothing but your present state. Okay, present. Okay, now what is the tricky thing is, you have to put t equal to plus 1. So plus 1 if you are putting means y of 1 will be equal to x of minus 1. X of minus 1 represents your what signal? X of minus 1 represents what signal? Just type in the chat box. X of minus 1 represents whether it is the present, past, or future. It is your past. Okay, it is your past. So after that, you have to substitute t equal to minus 1. Okay, then in this condition, y of minus 1 will be equal to x of 1. So x of 1 refers to what condition? X of 1 is, here it is minus 1 if you are putting in, here it is 1. So then it is future. Okay, it is future. So for this signal alone, okay, there is 3 states: present, past, as well as your future. Okay, so present plus past plus future means the signal will be non-causal. Okay, if the 3 states are also present means the signal represents a non-causal system. Okay, so in general you have to first put the 3 values. Okay, 0, 1, minus 1. Apart from that, if possible, 2 also you can put. Within these 4 values itself, you'll be getting to know the type of system. Okay, so this is what your causal and non-causal system, how you can find. Okay, the procedure to find it. Okay, so next thing we will be moving on. So next is the linear and non-linear system. Linear and non-linear system. Okay. So linear and non-linear you already know. That is, Linear means it will be moving in a straight path. Okay, so this will be a linear system. If this is x of t means y of t means, so the dependency is linear. So the dependency is linear. So it is going like this form. Okay, so it will be like this, or this is also a linear system only. This is also linear only. Okay, because here it is constant. Okay, the constant system is also, we can say it is a linear. So, but what you can say is the this kind of thing, that is exponential one. So this kind of things will be non-linear. Okay. So you can say this one is a linear. If the system response is like this linear. If the system response is like this, it is non-linear. Okay. So we can see with respect to this. So for this, I'll be giving some steps. Okay. Uh, so how they will be giving is, so how they will be giving, I will say, first they will be giving the signal. Okay. First they will be giving signal. Okay. Be giving x of t, that is x of t in terms of y of t. Okay. Or sometimes they will be giving y of t in terms of x of t. Okay. In such case means what you have to do is, in general, okay, so you have to find for x1 of t, that is, so they'll be giving y of t equal to in terms of x of t, they'll be giving. So this will be your output and this will be your input. Okay. So for step one you take for x1 of t, you have to find y1 of t. That is, you have to represent x1 of t in terms of y1 of t, you have to represent. Okay, what value you will be getting, you have to represent. Similarly, for x2 of t, you have to find y2 of t. Okay. After finding this, okay, after finding this, what you have to do is, you have to find step two. Step two, what you have to do is, you have to find y dash of t. You have to find y dash of t. Okay. So after this y dash of t, how you can find this y dash of t means it is summation of these two, y1 of t plus y2 of t. Okay. Okay. So after finding this, you have to again find y double dash of t. Okay. You have to again find y double dash of t, which is nothing but you have to take a derivative for this. Okay. So after this, what you have to do is the condition. Step 3 belongs to condition. So the condition is, if y dash of t equal to y double dash of t means, then your system is linear. Linear system. If it is not equal means then it is non-linear system. Okay. So this is the condition. With respect to this, you'll be getting into one problem. Okay. Then you will be able to understand. Okay. So you just take it down. These are the steps to find linear or non-linear system. Okay. You just take it down. So first you have to represent your x1 signal in x1 of t, then you have to represent in your x2 of t, you have to represent. Then what you have to do is you have to find the derivative. So derivative is nothing but the summation of these two things. Okay. So after that you have to take the second derivative. Okay. Then you have to check the condition. Now we'll be moving to the problem. Okay. Only example, small example for you to understand will be getting out. Okay. So the first thing is, so example number 12. Example 12. Example 12. So given the signal is y of t equal to t into x of t. The same signal what you have seen for causal or non-causal. As per a causal or non-causal, this signal is a causal system because there's only the present state. Okay. So to find whether it is linear or non-linear. Okay. So solution will be directly going. So you have to get with the step by step part. Okay. So first x1 of t, you have to replace with the x1 of t. For x1 of t, your y1 of t will be equal to t into, that is instead of x1, the x you have to replace with x1 of t. Okay. So next for x2 of t will be equal to y2 of t will be equal to t into x2 of t. Okay. So after this, okay, x1 of t we have one, x2 of t we have one. Okay. So after this, you have to find y dash of t. So your y dash of t is nothing but summation of these two is equal to y1 of t plus y2 of t is equal to t into x1 of t plus t into x2 of t. So now t and t is common, so you can take it out commonly. So t into x1 of t plus x2 of t. Okay. So now what you have to do is you have to find again x1 of t plus x2 of t. Sorry, in last step I didn't say about this. Okay, that is right. It will be a little bit confusing, but you have to understand. Here, what I have did was I asked you to take directly the derivative of this, but it's not like that. It's not like that. The thing is, y double dash of t. How you will be getting this? You have to So this for this y double dash of t, what we'll be doing is you have put to put x1 of t plus x2 of t. Okay, this value you have to put in your uh, directly in your this equation, first equation, y of t you have to put. Okay, so that is in the y of t you have to replace x like with this. Okay, now I'll explain this. So you'll be getting y double dash of t. So for this the thing is, yeah, there is two things. The signal, that is for x1 of t plus x2 of t, the value will be getting as y double dash of t, right? Output value is y double dash of t. Over here, what you have to put is, you have to put this in your, this thing you have to put over here. Okay, you understand, right? So this thing you have to replace with this x. Okay, this thing you have to replace with this x. So then what happen is, you'll be getting t into x1 of t plus x2 of t. Okay, okay, you understand, right? So in these two, for y dash of t, it's not like derivative. Okay, so it's not like derivative. I said we have to take derivative. So it's not like derivative. It's just like symbolic representation only. Y dash of t equal to y1 of t. You have to add these two signals. First, you have to represent the signal in terms of x1 for x1 of t, and then x2 for x2 of t. Then you have to add these two. Okay. Then for y double dash of t, you have to replace the given input signal with summation of these two input. So now we have to check whether y dash of t is equal to y double dash of t. Yes, it is equal. So the system is linear system. If you are solving some more examples, means you will be understand. Okay. This is what your example 12. So now we will be moving with example 13. Example 13. So the given thing is, it is given given y of t equal to 10 x of t plus 5. Okay. So here numbers are coming, so it will be easy to understand. So to find linear or non-linear. Okay. So we jump to the solution. So first what I have said, you have to represent in your x1 of t. So for x1 of t, your y of t will be y1 of t equal to 10 into x1 of t plus 5. Okay. So next, for x2 of t equal to y2 of t equal to 10 into x2 of t plus 5. Simply you are just replacing the subscripts. Okay. So next, y dash of t. Y dash of t is nothing but addition of y1 of t plus y2 of t. We will be getting summation of 10 into x1 of t plus 5 plus 10 into x2 of t plus 5. Okay. So now what common? So the common part is 10 in these two. So take it out. So 10 into x1 of t plus x2 of t So here 5 plus 5, you will be getting 10. Okay. So this is y dash of t. So now for y double dash, you have to put the input signal as x1 of t plus x2 of t. You have to substitute in here. You have to substitute in here. So you'll be getting y double dash of t equal to 10 into in the bracket x1 of t plus x2 of t. Okay. Then here is the part. You'll be getting the value plus 5. Okay. Here you are just replacing in your x only. Okay. But here you have after replacing you'll be adding both. Okay. So here there is variation. Here 10 is there. Here it is 5. Okay. So now y dash of t is not equal to y double dash of t. So you'll be getting the system to be non-linear system. Okay. So next we will be seeing in terms of your discrete one. Okay. So till now we have went with the continuous one. Now we'll be seeing with respect to the discrete one. Okay. The discrete thing. Example 14, I think. So given the signal is n square of n equal to yf. To find whether it is linear or non-linear. Okay. Solution. First you have to represent in your x1 of n. So for x1 of n is y1 of n equal to n square will be the same. Here it will become x1 of n. Similarly, for x2 of n will be y2 of n square x2 of n. So now for y dash of n, you have to add both y1 of n plus y2 of n. You will be getting n square x1 of n plus n square x2 of n. So now what happens is n square is common, you can take it out. N square equal to x1 of n plus x2 of n. Okay. So this is here y dash of n. Now next thing is for x1 of n plus x2 of n, will be getting your y double dash of n as nothing but you have to just replace this part. This x of n you have to replace this part. Okay. Will be getting n square into x1 of n plus x2 of n. Okay. So now we can say whether the system is linear or non-linear. So what is your answer? Just type in the chat box whether this system is linear or non-linear. Just type in the chat box. Okay, yeah. So your y dash of n is equal to y double dash of n. So your system is a linear. So next again we'll be seeing with the continuous problem. Continuous system. So example 15. Okay. So with this example, now we can go after this example. I can go to the next. Okay. So the thing is the given part. What they are giving is the signal is y of t equal to 10 cos 100 pi t into x of t. Okay. To find linear for non-linear solution. So now what you have to do is the same thing. X1 of t you have to replace. So you'll be getting y1 of t equal to 10 into cos 100 pi t into x1 of t. Okay. So the next is x2 of t. So y2 of t equal to 10 cos 100 pi t x2 of t. Okay. So next y dash of t, you have to add both the things, y1 of t plus y2 of t. So take the common out. Here these two are common, so you take common out. 10 cos 100 pi t, in the bracket you will be getting x1 of t plus x2 of t. Okay. The next part, x1 of t plus x2 of t will be getting, what will be getting, y double dash of t equal to 10 cos 100 pi t into x1 of t plus x2 of t. So whether the system is linear or non-linear, whether the system is linear or non-linear, whether the system is linear or non-linear. So it is the linear. Okay. So like this, you have to find your linear and non-linear system. So I'll just give some more problems. You just take it and do it as assignment. Okay. So this will be exam 15 we have covered. So you have to complete and practice it. Okay. So example number, take it as an assignment. Okay. You have to do it as a homework. So example number 16. The signal is y1 of t, sorry, y of t equal to t cube x of t plus 10. Yeah, this is one signal. So the next thing is example 17 is y of t equal to t into x square of t. Okay, so this is another one. So next example 18, y of t equal to e power x of t. So this you have to do complete in the next class. Okay, these three signals you have to complete in your next class. Okay. So now we'll be moving to your time variant system. Okay, time variant or invariant. How to say whether the system is time variant or time invariant. So this refers to that even if you're putting out some variation in your time period, the system must not be dynamic. It must be the same. Okay, if it is the same mean, then it is time invariant system, or if it gets altered means it is a time invariant system. Okay. So now we'll be dealing with the steps. Okay, steps to find whether the system is time variant or time invariant. So it is very easy to find. Step one, delay x of t by k units. So k is nothing but a constant. Okay, I can take it as a constant. Okay, and mark it as 1. Okay. So step 2, replace t with t minus k. Okay. You have to replace t with t minus k, and you have to take it as step 2. Sorry, equation 2. Okay, equation 2. So step 3. Step 3 is your condition. Condition step. The condition is if 1 is equal to 2 means the system is time invariant. Otherwise, the system is time variant. The condition. These are the steps. The 3 steps are there. It will be very easy. Okay. So now we can move on to the example. So example 1. Not 1, 19. Example 19. The given signal is y of t equal to t into x of t. The same signal we have already seen. Okay. To find time variant or invariant. Time invariant. Okay. So solution will be going on. So by step 1, signal is y of t equal to t into x of t. So step 1, you have to delay. Okay, delaying means what you'll be getting is y of t comma k will be equal to t into x of t minus k. Okay. Simple thing. In the time period, you have to replace delay with a k unit. Okay. You have to delay with k unit. Okay. This is nothing but a constant. So next, you have to step is you have to replace. You have to replace. So it will be y t minus k. Y t minus k. So instead of wherever there is a t, you have to replace with t minus k. It will be t minus k into x of t minus k. Okay. So this is your one. This is your 2. So it is clear that 1 is not equal to 2. So which determines your system is time variant. Next is example 20. Given example 20, signal is discrete signal A of n equal to log 10 x of n, log 10 x of n. Okay. To find time variant or invariant. The next is the solution. So first thing is write down the signal y of n equal to log 10 x of n. Okay. Now we have to delay. Delay the signal. So if you are delaying means you'll be getting y of n comma k equal to log 10 x of n minus k. Okay. So make it as equation 1. The next replace y of n minus k. That is wherever n is there, I have to replace with n minus k. We will be getting log 10 n, sorry, x of n minus k. It is clear that your equation 1 and 2 are equal. So your system is time invariant. This is what your time variant and time invariant means. So in next class we will be dealing with static and dynamic systems. Okay. So after that, stable and unstable system are there. So after finishing those things, I will be giving some normal definition. Okay. So from first unit, you can expect problems. Okay. You can even check it out with the last year question. Okay. So with this, I'll be stopping the lecture. Okay.